A man was murdered. There were no fingerprints to collect, no DNA to test, no cameras, no forensic laboratory. The killer had left almost nothing behind. But investigators still had a suspect. And somehow, they believed they could make the murderer reveal himself. The suspect denied everything. So the investigators tried something strange. They didn't look for fingerprints. They didn't search for DNA. Instead, they watched what the man said, what he refused to say, and how his story changed when the questions became more precise. Then something happened. A tiny detail in his story didn't make sense. And that single contradiction could be enough to decide whether he was a murderer, or an innocent man about to be punished for someone else's crime. But this wasn't a modern police investigation. It happened thousands of years before forensic science existed. So how did ancient investigators solve crimes? When the dead couldn't speak, the killer left no scientific evidence, and the truth had to be found another way. Imagine being responsible for solving a murder in the ancient world. You arrive at a house. A person is dead. There may be blood on the floor. Perhaps a broken object lies nearby. Maybe someone heard an argument. But there is no crime scene photographer. No fingerprint technician. No laboratory waiting to analyze a drop of blood. No database comparing DNA. And there certainly isn't a computer telling you where the killer went. Your investigation begins with something much more difficult. Observation. Who found the body? Who was nearby? Who had a reason to want the victim dead? What was the victim doing before death? What injuries are visible? And perhaps most importantly, does the story everyone is telling actually make sense? Ancient legal systems placed enormous importance on testimony, accusations, witnesses, and proof. In Babylon, the Code of Hammurabi even punished people who made serious accusations they could not establish. Judges themselves could face severe consequences for wrongful decisions. That tells us something important. Ancient investigators understood a problem that modern investigators still face. The person telling the story may be lying. But there was another problem. Sometimes, the dead body was the only witness left. Long before modern forensic pathology, physicians were already learning something incredibly important. Injuries leave patterns. A wound wasn't simply a wound. Its location mattered. Its depth mattered. Its shape mattered. And the condition of the body could tell an investigator something about what had happened. Ancient Egyptian medical knowledge, for example, included remarkably systematic observations of traumatic injuries. The Edwin Smith Papyrus describes wounds and head injuries, including observations about fractures and neurological symptoms. Researchers have noted how methodically these injuries were classified. Imagine what that meant to an ancient investigator. A body could no longer be treated merely as proof that someone had died. It could become a record of what happened. Was the injury consistent with a fall? A blow? A sharp weapon? Could the supposed accident actually have been an attack? And if someone claimed that a person had died naturally, the body might tell a very different story. But this created a new question. If the body could reveal the cause of death, could it also reveal when and how the person died? That question would eventually lead investigators into territory that sounds surprisingly modern. A corpse changes. Temperature changes. The body begins to decompose. Insects arrive. The surrounding environment affects what happens next. Modern forensic science uses these changes to help estimate aspects of the time and circumstances of death. But investigators did not suddenly discover these principles in modern laboratories. Centuries ago, Chinese officials were already recording observations about corpses and the circumstances surrounding death. And eventually, one man would bring many of these observations together. His name was Song Ci. He lived during China's southern Song dynasty. He was not simply a physician. He was a judicial official who personally dealt with difficult criminal cases. And in the 13th century, he compiled a remarkable work known as Shi Yuan Ji Lu, commonly translated as Collected Cases of Injustice Rectified or the Washing Away of Wrongs. The Library of Congress describes it as the world's first systematically written book of forensic science. But Song Si's goal wasn't simply to catch criminals. It was something even more important: to stop innocent people from being punished for crimes they didn't commit. Think about the difference between modern forensic science and ancient investigation. Today, investigators can sometimes preserve evidence for years. Ancient investigators had far fewer reliable tools. A wrong conclusion could destroy a person's life. And once an innocent person was executed, there was no way to reverse the mistake. This is why Song Si's approach is so fascinating. His work emphasized careful examination of bodies and injuries rather than simply accepting someone's accusation. The text discusses determining causes of death and distinguishing different circumstances, including murder, suicide, drowning, strangulation, and accident. The principle was revolutionary in its simplicity. Don't just listen to what people say. Examine what happened. That sounds obvious to us. But imagine how powerful that idea was in a world where authority, reputation, confession, and testimony could determine a person's fate. The corpse could challenge the witness. The wound could challenge the story. And the physical world could contradict the accusation. But then investigators faced an even stranger problem. Sometimes, the killer's weapon was still there. Return to that murder case. Several suspects. Similar weapons. No modern blood testing. No DNA. So how could investigators connect one weapon to the crime? The famous account recorded in traditions surrounding Song Si describes suspects being asked to bring their sickles to a central location. The investigators waited. Then flies were attracted to one particular sickle. The weapon's owner became suspicious. The logic was simple. Perhaps traces of blood remained on the weapon, even though they were not obvious to the human eye. The story is often presented as an early example of forensic reasoning involving insects and physical traces. Whether every detail of the traditional account should be treated as a scientifically proven reconstruction is another matter. But the larger historical point is fascinating. Investigators were beginning to understand that a crime could leave traces that humans might overlook. And that idea would become one of the foundations of forensic science. Because the criminal didn't need to leave behind a confession. They only needed to leave behind a trace. And here is where the story becomes darker. Ancient societies did not possess a modern scientific method. They had intelligent observations, but they also had beliefs and legal practices that we would now consider unreliable or unjust. In some places, accusations could be tested through ordeals. The Code of Hammurabi contains an example in which a person accused of sorcery could be subjected to a river ordeal, with the outcome treated as evidence of guilt or innocence. Imagine the terrifying logic. You are accused of a crime. There is no fingerprint, no DNA, no laboratory, and instead of evidence being scientifically tested, your survival may become part of the judgment. This reveals something crucial about the history of investigation. Humans did not move directly from superstition to modern forensic science. There was a long, messy period in between. People experimented. They observed. They guessed. They made brilliant discoveries. And they made terrible mistakes. The history of criminal investigation is therefore not simply the story of how humans learned to catch criminals. It is also the story of how humans slowly learned. How dangerous it is to be certain without evidence. When we imagine forensic science, we imagine laboratories, microscopes, DNA, fingerprint databases, chemical analysis. But the deeper revolution began much earlier. It began with a change in thinking. Instead of asking, "Who looks guilty?" investigators gradually learned to ask, "What actually happened?" Instead of trusting only a confession, examine the body. Instead of trusting only a witness, look for physical traces. Instead of assuming an accident, test whether the injuries match the story. And instead of treating every suspicious person as guilty, look for something that connects the person to the crime. This is why Song Si's work remains so significant. His book did not contain modern DNA analysis. It didn't need to. It helped formalize a much older principle. Justice should depend on careful examination, not simply accusation. Over centuries, the toolbox expanded. Investigators became increasingly interested in physical traces, bodies, weapons, blood, poison, documents, footprints, and eventually, fingerprints. Then came photography, microscopy, chemistry, toxicology, ballistics, and finally, in the modern era, DNA. The difference is enormous. A modern forensic scientist can sometimes extract information from a microscopic biological trace that an ancient investigator could never have seen. But the fundamental question hasn't changed. A body is found. A crime has happened. Someone is responsible. And investigators must reconstruct a sequence of events from incomplete information. The technology changed. The mystery didn't. Today, a detective can stand inside a crime scene surrounded by technology that ancient investigators could never have imagined. A tiny biological trace can be analyzed. A fingerprint can be compared. A digital camera can preserve the scene. A laboratory can identify substances invisible to the naked eye. And DNA can sometimes connect a person to biological evidence with extraordinary power. But underneath all of that technology is an ancient idea. Look closer. The killer may lie. A witness may forget. A suspect may change their story. But physical reality can leave traces. Sometimes those traces are obvious. Sometimes they are microscopic. Sometimes they are hidden inside a wound. Sometimes they are on a weapon. And sometimes they are simply inside a story that doesn't quite make sense. Thousands of years ago, investigators had none of the tools we take for granted today. Yet they faced the same fundamental problem. A crime had happened, and someone had to discover the truth. They did it imperfectly, sometimes intelligently, sometimes brutally, sometimes disastrously. But step by step, observation by observation, humans began transforming crime investigation from accusation into examination. And eventually, that journey produced something the ancient world could never have imagined. A science designed to make the smallest trace speak for the dead.